Hello everyone, this is Vahe coming to you with the Experiment 7x introductory video. So in this lab, in this experiment, we're going to be working with digital circuits and we're going to be simulating them. So as I've already mentioned, this particular experiment involves analyzing 4 different circuits. And I've given the circuits already in the lab report document, the template, which has already been uploaded. I also have them on a separate PDF file, which is over here. Okay, so these are both this PDF file and also the Experiment 7x report template have already been uploaded, and I'll go over them to describe what's going on. Okay, so the 4 circuits, they are very similar to the homework number 6 circuits, right? But they're not the same, but very similar. Okay, and we've gotten rid of those box AND gates and OR gates, the European style. So we just have 4 circuits. So here's circuit 1, okay, circuit 2, circuit 3, and circuit 4. And each one has certain inputs and certain outputs, and you're supposed to fill out the truth table, right? And you're supposed to show your work. Now when I say show your work, I mean show your work like how I did in the homework solutions. Just to remind you how that looks like, okay, here's how the homework 6 solutions look like. Okay, I don't mean you need to type it, you don't need to type it, but you need to show the work, you know, do it by hand, take a scan of it, take a picture of it, and upload it. So that can serve as your work. I mean, just for example, right? So this is problem 3 from the homework, okay? Not the same as the problem 3 that you're going to see in the experiment, but very similar. So what did I do? I went and took the columns ABC, put them on their side, and worked them through, and even showing the results right before the bubbles and so on. And what ends up are, you know, these intermediate values, and the boxed values are the ones that go on these columns D, E, F, G, right? So then once you have those values, then you can go ahead and fill out the truth table, right? Pretty straightforward, okay? So there are 4 circuits like this, and let's just jump to the report document. So here's how the report document looks like, as always, you know, name, email, stuff like that. Then when you jump in, okay, so here's the picture of the first circuit. And what do? For each circuit, there are 3 items to do, okay? The first item is to actually go and analyze the circuit, okay? And when you analyze the circuit, you should insert an image showing your work in this box right here, okay? Just insert your image. Like, for example, let's say you had done it like I had done, right? So you would just go here and you know, copy and paste this, you know, take a screenshot of this, okay? And then just go into here, all right, go into Word and just say paste the bitmap or whatever else you paste there, and there it is, right? That's your work, all right? And then once you've done that, you can go ahead and, you know, the table has moved, of course, but you can go ahead and fill this table, right? If you want, move this table to the next page or something, and just fill out the columns D, E, F, G with your results as a summary of your work, okay? That's item number 2, okay? Your handwritten work, for example, the summary of the handwritten work, item number 2. And item number 3 is basically a simulation results. Now I'm going to tell you how you can simulate these circuits, okay? But just understand that each of these 4 circuits is going to work the same way, right? You're going to analyze, show your work, copy paste, fill the table, simulation results, hopefully to verify what's on the table, and then you move to the next circuit. You do it again. So you do it 4 times, okay? And after this, you'll know these digital circuits like pretty well, okay? You won't have too much trouble with these circuits, how to understand, how to write the truth table, how to go through the ones and zeros. You know, you'll have plenty of exercise doing this. And then once you've done the simulation to verify it, you'll have even more confidence about your work. And that's the idea here, okay? So I'm going to also show you how you can verify the results of your work, right? So in other words, how do we enter a circuit like this into a simulation and get the truth table results, right? So I'm going to be telling you how you go about doing that. And just remember that you don't have to install anything. And what I'm going to show you is totally free, and you'll be able to use basically any browser to access it, okay? So in a few seconds, we're going to go and find out how to verify a simulation, how to verify the operation of a circuit. And we're back. So now I'm going to tell you about the simulator that we're going to use to verify our results. The name of the tool is called CircuitVerse. It runs directly from a browser, and there's nothing for you to install, and it's completely free. So this tool, you really don't have to create an account for, so you can use it directly by clicking on Launch Simulator or just clicking on Simulator up here, so you can use either one. But it really makes sense to maybe create an account just so you can keep some of your circuits saved in case you need to go back to them. If you don't create an account, then nothing is saved and you have to start from scratch every time you use the tool. Okay, so if you want to have an account, then you should go to Login, and on the bottom here it says New User Sign Up. Go ahead and create an account, and after you create an account, log in. So I've already created an account, and I'm going to log in right now. And I'm not a robot. Good to know I'm not a robot. And I log in, and when I log in, I sign in successfully, and I can go to my dashboard, or I can go to the simulator. You know, I can do all kinds of things. I can go back to my old circuits and things like that. But when you come in, this is what it looks like. So you have some elements on the left, and then you have some tools and circuits and projects and way to save the circuits on the top menu item area. And this is the canvas, and then you can zoom in and out of the canvas by using the mouse wheel like this. And so it's pretty easy actually to make some circuits. So before I talk way too much, let's just jump in and just put together a circuit and go from there. Okay, so let's say we want to simulate an OR gate, right? So where do we get the gates? Well, there's an item here called gates. Guess what? If you click on it, there are all the gates. Click on an OR gate, drag it in, now you have an OR gate. Maybe zoom in a little bit so you can see a little better maybe, and maybe move it around, right? So as you click on the left mouse button and keep it down, you can move the canvas around, okay? So there's a lot of little things like this you'll learn as you work with it. It's pretty simple to use. Now, let's have some inputs for these. And where are we going to get the inputs? Guess what? It has something called input. You go there and there's different kind of inputs. The one that we want to use is this one over here. Drag it in and then you have an input. So if you click on this box, you can change the input from a 1 to a 0. So you can choose anything you like. If you click away, the yellow highlight goes away, and so you deselect. So when you click on it, you're kind of selecting it, and then when you click on it again, you can change the value, and then you can unselect the item that you have. Now, let's have another input. Go get another one, drag it in. Now we have 2 inputs. Great. Now, the other thing about these inputs is if you look at the bottom here, so I have the bottom one selected, and by the way, it tells me, oh, you should save your file. Let's do that. Let's just save the file. Let's just call it sample, right? Or sample 1. There we go. Okay, now it's saved. And then update project to make sure everything is updated. And here's our little save file. There's not much to it, but that's what we have, right? And then launch simulator to go back and, you know, go back to where we were. So that's how you actually save a file, and then you can just zoom in to where we were and continue on. And I'll show you how to save it along the way as well. So what was I saying? Well, this item here, right, you can label these, right? So I can go here and say, I want to call this A. So with this square input highlighted, I can go down here and call that A, and it'll label it for me. Same thing for this one down here. Highlight that, go to label, label it B. Okay? So now I have my two inputs, A, B, and then I can wire them by going to these dots, right? And then just dragging to the next dot that I want to connect to. And as you notice, what happens is that actually, if you have a high input, one input, that line is a light green, and when the input is a 0, it's a darker green, right? And as I change the ones and zeros over here, you see the line colors changing, right? Okay, so now I have an input and another input. I have two inputs. Now I want to measure the output of this OR gate, and guess where I'm going to go? Output? You'll be right. So here's the output, and you grab it and put it right here, and then connect it as we have it. And then as you change the inputs, you see the colors are changing, the inputs are changing. So this is a live circuit, and you can just click these values and just work through. Now, after you updated the circuit, you might want to go back to project and say, yeah, I want to save online again. And again, it's saved. Okay. Now go back here, and we can do more things. All right. So far, so good, right? Looks pretty simple. Now, let's actually build another circuit. Okay. But this time, let's build a circuit with multiple inputs at once, right? In other words, suppose we wanted to do what we did on the homework, where we feed in the entire column at once, right? How do we do that? You want to feed the entire column at once. Well, what we can do is we can simply go and change the widths of these inputs. Like the A right now, if I click on it, right? And if I look at the bottom, it says it's called A, labels A, and the bit width is 1, right? But really, if I want to have 4 inputs at once, right? 4 rows basically is what I'm talking about. I can just go up and change it to 4. Now, when I do that, I get what is called bit width error. You'll see it when I do this with the B as well, right? See, it says bit width error. The reason for it is because right now, the OR gate and also the output, if you click on them, you see that their bit widths are 1. So if you're going to have a width of 4, everything has to have a bit width of 4, right? So I need to go and update the bit widths and make sure it's actually operational. So let me go to B here, change its bit width to 4, right? Basically 4 rows. And then I need to go to the OR gate, change its bit width, right? And then go to the output, obviously, and change its bit width. Now, if I knew I was going to have 4 from the beginning, right, I would have gone and updated those from the beginning. There would have been no reason to go and do any kind of a change, right, at the end, like I'm doing now. I'm kind of updating it. And after you update it, you need to make sure that things are working properly by clicking on a few things, right? So if I put in all zeros like this, I should have a 0 at the output, right? And then if I have 0, 0, 1, 1, 0, 1, 0, 1, well, that's kind of my input set, right? So if you've done the homework, you can see how this is very straightforward. And let's save this, right? Let's save this again. Save online. And now it's been saved. So we're ready to go. And we're in business. All right. What else can we do? Well, actually, you can do the same thing with width of 8, right? So if I want to, I can have a width of 8. Let's start a new project, okay? Let's say new project. Okay, let's save it. And then, let's get width of 8. So how do we do that? This time I want to be more efficient, right? I know I'm going to have a width of 8. Let's say I want to do 3 inputs, right? I want to have 8 possibilities. So I'm going to take my input, put it here. Let's zoom in. And I know right away, let me call this A. Okay, let me call that A, like that. And I know right away that it's going to have a width of 8. So just go there and put an 8. And you're already in business, right? And I can change the 1s and 0s later on. Now, if I want to copy and paste this, very simple. Hold the shift down, select, right? It's selected now. Control C, copy, and then Control V, right? And then another one, Control V. The only problem is they are called A's, but but I want to update these values, so I can click here, for example, and go down there and say, well, I want to call that B, right? And then I can click on this here and call that C, all right? And then later on, I can adjust the A's and B's to anything that I want. For example, A could be 000111, B could be 0011, 0011, and then C could be 0101, 01. That's it, right? Pretty easy. Pretty easy. Those are my columns. What circuit would I put there? Well, whatever circuit I choose should have a bit width of 8. So it's up to you how you want to do it, right? So maybe we'll just go get some gates, right? Let's just do that. Maybe we'll get a AND gate here, right? We'll get maybe a NAND, and we'll get an OR. I mean, I'm just kind of randomly picking these, right? But I want to make sure that each one that I pick, so for example, I'm going to highlight the AND first. I want to make sure its bit width is 8 because it's got 8 inputs to handle, right? Same thing with the NAND. Just change those to 8. Very, very easy. And once you've done that, you're going to be in business. Okay, should I save this? Absolutely. So maybe call it sample 2. Right? Sample 2. And here it is. Save it. Update the project. Go back to the simulator. We're in business, right? So it's saved. You know, you can go back to it. And how do you go back to it? When you're logged in, you can just go say dashboard, and dashboard will list all your programs. Let me go back and show you. Okay, leave site. I don't want to leave the site, but you know, it just shows something like this, right? It just shows, this is the dashboard right here with all your circuits. This is how it'll look like. And then if you have a circuit that you want to launch, you just say launch, and then it'll go over here, basically. It'll go to that circuit, open up the simulator. Okay, so I think we have all these to be bit width. Oh, this one doesn't have a bit width yet. Oh, wait, here. So if I just click on it, I can see 8 bits, 8 bits, 8 bits, and then these are 8 bits. I'm ready to go. Now I just wire it up, right? I just wire it up as I please. How does the circuit look like? Well, I didn't say how it was going to look like, so I can wire it up as I wish, like this, and maybe it looks sort of maybe like this, and maybe B goes over here, and then maybe this one goes over here like this, right? Click, click. You can figure it out. It's pretty easy to use. And then maybe an output here, right? And now, you know, I have these inputs, and you know, maybe I can kind of move them around, adjust them if I want to. You know, maybe you can do something like this and get crazy with it. And now what happened? Well, it got broken, right? So what do you do in this case? Well, okay, you just kind of throw it away, right? So how am I going to fix that? Just do a shift and then just select and just delete. This is what you should do. So I did it on purpose to show you what happens when you have something like that. Just start from scratch. It's pretty easy. Just get a gate. Here's the OR gate that I had, right? So it's pretty easy. Don't bother with trying to fix it, right? It's that easy. Okay. The only thing you gotta make sure is that, remember this thing now? It's got a bit width of 1. So make that an 8, and you shouldn't be in business now. This should work. Now the thing is, how do you get the outputs? Get the output, right? And you know, get one of these, for example, and make sure that this is a bit width 8 also, right? And you'll see right away. It'll pop up, and then you can also zoom out like that to the width, and you can show it, and then just wire it up again. It's pretty straightforward, right? And then if you want to display the other outputs, right? So this is one output. If we do Control C and Control V and Control V over here, right? You can also display, for example, this output, and then you can display, for example, this output. And yes, you can go on this and call the label, for example, you know, F, for example, and maybe this output here is D, right? Great, it works great. All right. What else can you do with this? Well, one thing you should do is you should put some text on this to make sure that you know where this is coming from, right? So the way you do that is you go to miscellaneous and go to text and then put the text wherever you like. And once you're in there, just go in and type, say, you know, a sample circuit. Or you know, for the lab, you can just say something like this. Circuit number 1, right? Or you could even say, you know, experiment, right? You can go in here and say experiment 6, circuit number 1, and you can put your name here, right? You can say experiment whatever. So it's up to you how you want to do that, and then once you put it down, you can position it, right? And the label is right here, so you can go to the beginning of it and just type in, for example, EC, you know, experiment 7X, circuit number 1, right? And it's documented, and then you can also save it to make sure it's saved. Save online. It's saved now. It's good. It's good to go. The only other thing you need is, how do you get this, right? Because you simulated it now, and hopefully this match your results. How do you get this back to the document? You can capture the screen, but there's an easier way, okay? And that easier way is through the Tools option. So if you go to Tools, Download Image, there's different image types you can choose here. I'm going to choose Portable Network Graphics, Full Circuit View, Transparent Background, and a 4x resolution. Render circuit image. It just did it basically. And when you open up the folder, you'll see the picture up here in whatever tool that you have. It'll look like this. It looks like a black background, but what it has done is the background is transparent right now. When I import it, you'll see how it looks like. So I know where it is. So if I go to my Word file, and this is the last thing I'm going to actually say, is let's go to the Word file that is that I was showing you before. So let's go to my 115 folder, labs. Okay, so let's go to the doc file, which is this. Okay, so let's say you are, you know, you've done the analysis, you pasted your analysis as I showed you, you filled the table, and now you want to put your simulation result here. I mean, just insert the image. The image, you know, I don't even have to tell you how to do it because I think you guys know it better than me. You just go to where the image is and insert, and there it is, right? And then your name appears on it, right? I want your name to appear on it so that we know it's from you and not from somebody else. Okay, and that's all there is to it. It verifies your work. Now, of course, this circuit doesn't verify. Okay, this result doesn't verify this circuit. I'm just kind of showing you how the way you approach the problem. Okay, and this is a good workflow, right? You have the circuit, you analyze it by hand, you fill out the table, and then you run the circuit simulation tool to make sure your results are correct. You verify your results, you move on to the next circuit. This is typically how engineering is done. You have to verify your work. And so if you have more than one way of calculating something, you should do it. Okay? So I hope that you like this tool. It's called CircuitVerse. And it's a slick tool because you don't have to install it, and it runs very quickly. It runs from a browser, and it's very useful, and it's easy to use. Also, I know for a fact that we use this exact tool in ECE 265, which is about digital circuits. The whole course is about digital circuits. So ECE 265, which is a requirement for both EEs and CEs, okay, they use this tool. So if you learn this tool now, you'll be ahead of the game, way ahead of the game, when you come to that course. Okay? So all these tools we're teaching you are tools that we use down the line, and you'll be able to utilize the skills that you learn here, and they'll help you out tremendously down the line. Okay, so thanks very much. I hope this helps you out. It's an easy tool to use. I think you're going to have a lot of fun. Start early, and if you get any errors, let me know. But the typical error that you get is the bit width error, which means that if you have everything has to have the same bit width. If not, it gives you an error basically, saying that there's an inconsistency. Other than that, I think you're going to have a good time with this tool. Thanks very much. I appreciate your patience. I hope everyone is doing well, and I hope you are staying safe. So take care, and I will see you next time.